Hi friends, in this video we'll discuss about fuels and combustion. Fuels and combustion is one of the most important chapters from energy manager certification exam point of view. Many questions are expected from this chapter. I have simplified the topics so that you can easily understand the subject and remember the contents from energy manager certification exam point of view. Each and every topic is important in this chapter. If we understand the topics clearly, then it will not be difficult for us to answer the questions. I would like to request you to subscribe my channel and share the videos with your friends. Let us discuss about the type of fuels. There are three types of fuels. They are liquid fuel, solid fuel and gaseous fuel. Liquid fuels are combustible or energy generating molecules that can be used to create mechanical energy, usually producing kinetic energy. They also must take the shape of their container. It is the fumes of liquid fuels that are flammable instead of the fluid. The second type of fuel is related to solid fuel. Now, solid fuel refers to various forms of solid material that can be burned to release energy, providing heat and light through the process of combustion. Some examples of solid fuels are wood, charcoal, coal, agricultural residues, etc. The third type of fuel is gaseous fuel. Gaseous fuel means a material that is in the gaseous state at standard atmospheric temperature and pressure conditions and that is combusted to produce heat or energy. Now coming to some of the advantages. Number one advantage is calorific value of liquid and gaseous fuels is higher than the solid fuels. Number two advantage is liquid and gaseous fuels have higher ignition temperature than the solid fuels. Number three advantage is liquid and gaseous fuels are easier to store since solid fuels occupy lot of space. In this video, we will discuss about liquid fuels only. Some of the examples of liquid fuels are furnace oil, LSHS, LDO, gasoline, kerosene, LPG, etc. A liquid fuel used in homes is liquefied petroleum gas or LPG. Furnace oil, LSHS, and LDO are used in industries. Cooking, lighting, and heating are the main household services provided by kerosene. Gasoline is the most common automobile fuel and is used all over the world to power cars, motorcycles, scooters, boats, and other machineries. Now, let us discuss about the properties of a liquid fuel. These properties are density, specific gravity, viscosity, flash point, pour point, specific heat, calorific value, sulfur, ash content, carbon residue, and water content. Density is one of the important properties of fuel. Density is the ratio of mass of fuel to the volume of fuel at 15 degrees centigrade. Density is measured by an instrument called hydrometer. Density is required for calculating the quantity of fuel to be used. Higher density indicates more weight of the fuel for the same volume. So less fuel will be required for higher density fuel. Density is also required to evaluate the ignition quality. It will be difficult to atomize a denser fuel. So ignition of a denser fuel will be difficult in comparison to a less denser fuel. The unit of measurement of density is kg per meter cube or gram per centimeter cube or gram per cc. Now let us discuss about specific gravity of liquid fuel. Specific gravity is the ratio of given volume of fuel to the weight of same volume of fuel at given temperature. Specific gravity is nothing but the density of fuel with respect to water. If it is less than 1, then it means the liquid is lighter than water and if specific gravity is more than 1, then the liquid is denser than water. In case of water, the specific gravity is 1. Since specific gravity is the ratio of two densities, it has no unit. Specific gravity is measured with hydrometer. Specific gravity of some of the liquid fuels have been shown in the table. The specific gravity of LDO varies from 0.85 to 0.87. The specific gravity of furnace oil varies from 0.88 to 0.98, and the specific gravity of LSHS varies from 0.88 to 0.98. Let us discuss about another property of liquid fuel, that is viscosity. Viscosity is the internal resistance to flow. That means a liquid having higher viscosity offers higher resistance to flow. So a higher viscous liquid will not flow easily compared to a liquid having lower viscosity. Viscosity also depends on temperature of the liquid. When temperature increases, viscosity of a liquid decreases and it flows easily. Viscosity of a liquid has to be specified at a given temperature. Viscosity is measured in Stokes or centistrokes, Angler, Seabolt, Redwood, etc. Viscosity is measured in viscometer. Viscosity is important from the point of view of storage and use of fuel. That means for storing a higher viscous liquid, fuel like heavy furnace oil, heating arrangement has to be done in the storage tank to facilitate its flowability. Similarly, for a lower viscous fluid, fuel like LDO, heating arrangement is not required at the storage tank. For handling, storage and satisfactory atomization, degree of free heat depends on viscosity. If a viscous liquid is not atomized properly, then there will be carbon deposits on burner tips or on the water walls of the boiler. So preheating of viscous liquid is required for proper atomization. Let us discuss about another property of liquid fuel, that is flash point. Flash point is the lowest temperature at which a liquid gives up momentary flashes when exposed to open flame. In other words, the flash point of a liquid fuel is the temperature to which it must be heated to emit sufficient flammable vapor to flash when brought into contact with a flame. As shown in the picture, the flash point of gasoline is minus 23 degrees centigrade. When gasoline is exposed to fire from a matchstick, then it catches fire at room temperature. At the same time, diesel, whose flash point varies from 55 to 66 degrees centigrade, does not catch fire at room temperature when exposed to a open flame from matchstick. The flash point is an important concept in fire investigation and fire protection because it is the lowest temperature at which a risk of fire exists with a given liquid. It is crucial in many circumstances to establish the presence of some liquids and to know their flash point during the investigation process. Let us discuss about another property of liquid fuel, that is pour point. It is the lowest temperature at which oil flows in a specified lab test. Specifically, the pour point is 3 degrees centigrade above the temperature at which oil shows no movement when a lab sample container is held horizontally for 5 seconds. If the surrounding temperature is less than the pour point, it cannot be transferred through a pipeline. Pour point is more significant for lubricating oils. Pour points provide the lowest temperature for that fluid at which it can transfer by pouring. Let us discuss about another property of liquid fuel, that is specific heat. It is the amount of heat required to raise the temperature of 1 kg of fuel by 1 degree centigrade. From the picture, you can see that heat is added to two different liquids having different specific heats. The liquid whose specific heat is less heats up easily as less heat is required to raise its temperature by 1 degree centigrade. The unit of measurement is kilocalorie per kg degree centigrade or joule per kg Kelvin. Light oils have low specific heat, whereas heavier oils have higher specific heat. For example, LDO has less specific heat compared to heavy furnace oil, so less heat would be required for LDO to reach its ignition temperature in comparison to HFO. Let us discuss about another property of fuel, that is calorific value of fuel. It is the amount of heat released during combustion or the heat produced by the combustion of a unit weight of fuel. From the picture, you can observe that LPG has higher heat content or calorific value compared to fuel oil, LDO and HSD. Calorific value is measured either as gross calorific value or as net calorific value. When combustion of fuel takes place, heat is released. During this process, the moisture present in the fuel absorbs some amount of the heat. At the same time, the hydrogen present in the fuel reacts with oxygen and is converted into water. This water also absorbs some amount of heat liberated during combustion of fuel. So net calorific value is calculated by subtracting the heat absorbed by moisture from the heat of combustion. Gross calorific value is the total amount of heat liberated during combustion process, which does not take into account the heat absorbed by moisture. We can also say that the difference between gross calorific value and net calorific value is the latent heat of condensation of the water vapor. Let us go through the gross calorific value of some liquid fuels. From the table, we can see that the gross calorific value of kerosene is more compared to other fuels mentioned in the table. Now coming to the relation between gross calorific value and net calorific value. Gross calorific value is equal to net calorific value plus 584 multiplied by 9H2 percentage plus M percentage divided by 100, where H2% is hydrogen percent by weight present in the fuel, M percent is moisture percent by weight present in the fuel, 584 is latent heat corresponding to partial pressure of water vapor in kilocalorie per kg. This is a very important formula and few numerical may be expected from this formula. Sulfur is an important constituent of liquid fuel. It is converted into sulfuric acid where sulfur trioxide, which is a product of combustion, reacts with water. Sulfuric acid is corrosive in nature and affects metals. Sulfuric acid condenses in chimney, air preheater and economizer when it reaches dew point. This corrodes the component. In the picture, you can see the corrosion of a metallic component due to the effect of sulfuric acid. Now let us discuss about the sulfur content of some of the liquid fuels. From the above table, you can see that furnace oil has the highest sulfur content in comparison to other liquid fuels. Let us discuss about another important constituent of fuel oil, that is ash content. It is an indication of the inorganic material in the fuel oil. Ash content in the fuel oil varies from 0.03 to 0.07%. Excessive ash leads to deposits in combustion chamber. Ash has erosive effect on burner tips. It also gives rise to high temperature corrosion and fouling of equipment. Now let us discuss about carbon residue in oil. The carbon residue provides information on the carbonaceous deposits which will result from combustion of fuel when the vaporizable constituents of fuel evaporate. For fuels with high carbon content, it is difficult to burn them fully, which results in increased deposits in the combustion chamber. Carbon residue is an indication of the fuel to decompose and form carbonaceous material that can plug diesel fuel injection nozzles. Now, let us discuss about water content in liquid fuels. Water may be present in free or emulsified form in liquid fuel. If water contains dissolved salts, then it damages the furnace internals during combustion of liquid fuel. Water also causes spluttering of the flame at burner tip. That is, it makes a series of short explosive spitting or choking sounds at burner tip. Spluttering has a tendency to extinguish the flame, to reduce the flame temperature, or to lengthen the flame. Now, coming to storage of fuel oil, furnace oil should not be stored in barrels as it is hazardous. This should be stored in cylindrical tanks above or below ground. It is recommended that there should be a storage of 10 days normal consumption in the tank. Bond walls should be constructed around the tank to restrict spreading of oil to the surrounding area in case of unexpected spillage. There will be deposition of solids and sludge at the bottom of fuel oil tanks over a period of time. To overcome this, the heavy furnace oil tanks and light fuel oil tanks should be cleaned in every 2 years. Fuel oil is very precious. The loss of one drop of fuel every second costs over 4,000 liters a year. The fuel oil which comes to plant in tankers may contain contaminants which may choke the line or which may damage the pumps. So to remove the contaminants, strainers are provided at different locations like between tank decanting point and storage tank, between service tank and preheater, between preheater and burner. The selection of sizes of strainers are different for different locations like 10 mesh size strainer should be used between tank decanting point and storage tank. This 10 mesh size consists of 3 holes per inch. Similarly, 40 mesh size strainer should be used between service tank and preheater. This 40 mesh size consists of 6 holes per inch. Similarly, 100 mesh size strainer should be used between preheater and burner, which consists of 10 holes per inch. Now, positive displacement pumps are used for pumping of heavy fuel oils which are having higher viscosity. Gear pump has longer life in comparison to diaphragm pump. It is easier and less expensive to repair diaphragm pumps. Centrifugal pumps are not used for viscous liquids. Efficiency of centrifugal pump decreases sharply as viscosity increases. Power required for pumping also increases with increase in viscosity. Light fuels are best pumped with the help of centrifugal pumps or turbine pumps. For higher pressure applications, piston or diaphragm pumps are used. Now, coming to fuel storage and pumping temperature, as temperature decreases, the viscosity of furnace oil and LSHS increases. So the pumpability of these liquid fuels decreases as temperature decreases. Furnace oil is not pumpable at atmospheric temperature, so oil is preheated to make it pumpable. The entire oil tank may be preheated and steam coils are used at the bottom of the tank for such application. The steam pipelines leading to steam coils are fully insulated to minimize radiation heat loss. The oil can also be preheated at the outlet of the pump with the help of heaters. Steam is also used in this case for preheating of oil. The entire fuel oil tank as well as the preheaters are insulated to minimize radiation heat loss. Electricity can also be used as a heating medium for the oil heater. Let us discuss about temperature control of oil. As oil flow is reduced or stopped, the oil will be overheated if the steam admission quantity is not decreased or electricity is not controlled. So to ensure this, thermostatic temperature control is used. This is extremely important for electric heaters as oil may get carbonized when there is no oil flow and the heater is in service. In case of steam preheaters, control valves are provided to control the steam temperature of oil. Thermostats should be provided at a region where the oil flows freely into the suction pipe. The pumping temperature of oil depends on the grade of oil being used. Higher storage temperature of oil than required for pumping of oil leads to energy loss.